Pagod ka na bang magsulat ng contact tracing form sa bawat pinupuntahan mo? Natatakot ka bang mahawa dahil sa panulat na ginamit mo? Nangangamba ka ba para sa iyong data privacy? Higit sa lahat, may saysay nga ba ang mga pinagsusulat mo? Upang bawasan ang ating alalahanin sa tuwing magtutungo sa mga establishmento ngayong meron pa ring COVID-19 pandemic, ay ginawa nating mas madali ngunit mas maiting ang ating contact tracing sa Valenzuela City. Narito na ang Valenzuela Contact Tracing App o ang ValTrace. Sa pamamagitan ng ValTrace App, hindi na kailangan pang magsulat sa contact tracing form sa bawat pupuntahang establishmento. Kailangan lang ipakita at i-scan ang inyong unique QR code. Ang record ng inyong mga napuntahan ay direktang maitatala sa database ng ating Mega Contact Tracing Center na magiging malaking tulong para sa mas masinsinang contact tracing. Paano ba gamitin ang ValTrace app? Step 1. Mag-log on lang sa valtrace.upcase.net. Step 2. Sagutan ang online form at i-click ang Submit. Step 3. I-generate ang inyong QR code at i-save sa mobile phone. Maaari din itong i-print. Narito ang ilang paalalang dapat tandaan. Simula September 12, 2020 ay pwede nang i-download ang inyong QR code. Sa October 5, 2020 naman ay sisimulan ng hingin at i-scan ang inyong QR code sa bawat enclosed indoor establishment sa Valenzuela City, tulad ng mga mall, restaurant, grocery store, bangko, simbahan, palengke at iba pa. No QR code, no entry. Kaya mag-download na upang hindi maabala. Ang serbisyong ito ay libre at pwedeng gamitin taga Valenzuela ka man o hindi. Bawat isang QR code ay para lang sa isang tao, kaya dapat ay may sariling code ang bawat individual na papasok ng establishmento. Kailangan pa rin palaging dalhin ang quarantine pass sa tuwing lalabas ng tahanan. Ang QR code ay kakailanganin lamang tuwing papasok ng establishmento.
Good morning to all of our viewers for today. Today, you must be able to learn the following. First is to factor completely polynomials using the greatest common monomial factor or GCMF. And to factor polynomials using the difference of two squares. And then, we are going to apply these factoring methods in solving word problems. Are you ready? If you are, then let us start our lesson for today with a game. Let us play Who Wants to Be a Math Millionaire? The rules for this game are pretty much simple. All you need to do is to answer the question that will be flashed on your screen. Choose the letter of the best answer, and you can also key in your answer in the comment section. Are you ready? If you are, then let us start with question number 1. What is the greatest common factor of 6, 12, and 24? Is it letter A, 2. Letter B, 4. Letter C, 3. Or letter D, 6. You can type your answer on our Facebook Live. And the correct answer? It's letter D. Very good. Are you ready for question number 2? Let's have question number 2. Which of the following is not a perfect square number? Do you think it's letter A, 1, letter B, 4, letter C, 8, or letter D, 9? You can start typing your answer. And the correct answer? It's letter C. Very good. Question number 3. Which of the following has the least exponent? Is it letter A, m cubed? Letter B, m to the 4th? Letter C, m to the 5th power? Or letter D, m to the 8th power? I hope you got this one right. And the correct answer? It's letter A. Very good. Are you getting the hang of it? Let us continue. Which of the following is a perfect square? Is it letter A, x? Letter B, x squared? Letter C, x cubed? Or letter D, x to the 5th power? Start commenting your answer. Do you think you got the correct answer? Of course, it's letter B, x squared. Are you ready for our final question? Which of the following is a difference of two perfect squares? Letter A, y squared minus 8. Letter B, y squared minus 9. Letter C, y cubed minus 8. Or letter D, y squared minus 9. Make sure you key in your answer in the comment section. And the correct answer, it's letter D, y squared minus 9. Very good. Did you enjoy our activity? If you do, I hope it helped you to remember the different topics from your grade 7 discussions, because this will help you in our lesson for today. So to start our lesson, let us first define what do we mean by greatest common monomial factor. Greatest common monomial factor, or GCMF, is the largest monomial that divides all the terms of a given polynomial. And how do we determine the GCMF of a given polynomial? It is simply the product of the greatest common factor, or GCF, of the numerical coefficients and the constant term, and the smallest power of the variable that appears in all the terms. We'll be using a lot today GCF. So I hope you can still remember what GCF, or greatest common factor, means. And how do we determine the GCF of a given number? So the most common method in determining the greatest common factor is using factor trees or prime factorization, as you can see in our example. Are you ready? Let us have some examples. Let us find the greatest common monomial factor of 2x squared, 4x, and 6x cubed. First, let us determine the GCF, or the greatest common factor, of 2, 4, and 6. So the greatest common factor of 2, 4, and 6 is 2, since 2 is the largest number that divides 2, 4, and 6. Next, we determine the smallest power of x. The smallest power of x is 1. And by multiplying 2 and x, therefore, our greatest common monomial factor is 2x. Let us have another example. Let us find the greatest common monomial factor of 12mn to the fourth and 18n cubed. Again, first, we determine the greatest common factor of 12 and 18. The largest number that divides 12 and 18 is 6. And then, we determine the smallest power of n, which is n cubed. Multiplying 6 and n cubed will give us our greatest common monomial factor, which is 6n cubed. If you will notice, we did not include m in our greatest common monomial factor, since it does not appear in 18n cubed. Are you getting the hang of it? Let us have some more examples. How about trying to factor completely the given 3y squared plus 6y cubed minus 12y to the fourth power? Applying the same method, we first determine the GCF of 3, 6, and 12, which is 3. And then, we determine the smallest power of y, which is y squared. Multiplying the GCF and the smallest power of y, therefore, our greatest common monomial factor is 3y squared. But wait, we are asked to factor completely the given polynomial, which means that we also need to determine the other factor aside from the GCMF. Let us continue our solution. To determine the other factor, we must divide each term of 3y squared plus 6y cubed minus 12y to the fourth using the GCMF 3y squared. If we divide 3y squared by 3y squared, the answer will become 1. If we divide 6y cubed by 3y squared, the answer will become 2y. And if we divide negative 12y to the fourth power divided by 3y squared, the result will be negative 4y squared. Therefore, the other factor is 1 plus 2y minus 4y squared. And the complete factor form is 3y squared times 1 plus 2y minus 4y squared. Did you get our example? Let us have another one. How about factoring completely x quantity 3x plus 2 minus 5 quantity 3x plus 2? Again, we determine the common factor, which is 3x plus 2. And using reverse distributive property, the other factor is quantity x minus 5. Multiplying the two polynomials, therefore, the complete factor of x, quantity 3x plus 2 minus 5, quantity 3x plus 2, is quantity x minus 5 times quantity 3x plus 2. But there are times that after getting the greatest common monomial factor, the other factor will result to a polynomial which is factorable using a different factoring technique. For an instance, let us try to factor 3y cubed minus 12y. So first, we take out the greatest common factor of 3 and 12, which is 3. And then, we determine the smallest power of y, which is y. Combining 3 and y, multiplying it, will result to the greatest common monomial factor, which is 3y. But again, we need to factor completely the given polynomial. So we divide each term of 3y squared, 3y cubed rather, minus 12y, using the greatest common monomial factor, 3y. If we divide 3y cubed divided by 3y, it will result to y squared. And if we divide negative 12y divided by 3y, it will result to negative 4. Therefore, the other factor is y squared minus 4. But then again, this type of polynomial is factorable by a different factoring technique. And what factoring technique can we use? Let me introduce you to the difference of two squares. But how do we factor polynomials using the difference of two squares? First, you must determine if the given polynomial is a binomial, whose terms are both perfect squares. And also, the operation must always be subtraction. Now, if the given polynomial or binomial satisfies the characteristics of the difference of two squares, we can now proceed to factoring y squared minus 4. We first get the square root of y squared equals y, and then we determine the square root of 2, disregarding the sign, equals 2. Then we write our final answer, y squared equals to quantity y plus 2 times quantity y minus 2. If you can still remember, we already have a GCMF of 3y. So we need to multiply all the factors. Therefore, the complete factor of 3y cubed minus 12y is 3y times quantity y plus 2 times quantity y minus 2. Did you understand? How about factoring another polynomial, which is factorable using the difference of two squares? Let us have 4m squared minus 49. Again, first, we check if the given polynomial is factorable using the difference of two squares. Since both of the terms are perfect square and the operation is subtraction, therefore, we can use difference of two squares in factoring 4m squared minus 49. First, we get the square root of 4m squared equals to 2m. And then, we get the square root of 49, disregarding the sign, equals 7. Writing our answer in the form of the product of sum and difference of two terms, therefore, the factored form of 4m squared minus 49 equals to quantity 2m plus 7 times quantity 2m minus 7. I hope you understand the different examples that I presented to you. Always remember that before you can factor out a polynomial using the difference of two squares, you must first check if both of the first and last terms are perfect squares. And then, check if the operation is subtraction. Now, here are some examples of polynomials which are factorable by the difference of two squares. And here are some examples of polynomials which are not factorable by the difference of two squares. Because if you will notice, these polynomials have an operation of addition, or some of them has an operation of addition. And some of the given polynomials has terms which are not perfect square. Let us now apply what we had learned from the different examples. And also, let us apply this table in determining the difference of two squares of a given polynomial. Now, how are we going to use this table for an instance in determining the difference of two squares? Because if you can easily remember the square roots or the principal roots of a perfect square number, then you can easily get the square root of a given polynomial which is factorable by the difference of two squares. So this is just my list. You can also create your own list by simply multiplying by itself. And here are some examples of perfect square monomials which are factorable using the difference of two squares. We can get the square roots of these monomials by simply dividing the exponent using 2. Now, let us try to solve some word problems. How about this one? A rectangular lot in Malinta, Valenzuela City has an area of quantity 6x squared plus 2x square meters. Determine the dimensions of the lot. So our task for this word problem is to simply factor out 6x squared plus 2 using the greatest common monomial factor. So factoring 6x squared plus 2x, we determine the GCF first, which is 2, and we determine the smallest power of x, which is x. Multiplying 2 and x will give us our GCMF, which is 2x. And then to determine the other factor, we simply divide 6x squared plus 2x by the GCMF 2x, which will result to the other factor, 3x plus 1. Therefore, the dimensions of the rectangular lot are 2x meters and 3x plus 1 meters. Let us have another example. Mang Pio bought a picture frame which has an area of quantity 9x squared minus 25 square meters. Find the dimensions of the picture frame. So our task for this given word problem is to factor 9x squared minus 25. Always remember, when we are factoring polynomials, we must check first if the given polynomial is factorable using the greatest common monomial factor. Since the greatest common monomial factor of 9x squared minus 25 is 1, therefore, we can now proceed to a different factoring technique. And what factoring technique is that? Let us first check if the given polynomial is factorable using the difference of two squares. Since both of the terms are perfect square and the operation is subtraction, therefore we can use the difference of two squares in factoring the given polynomial. Getting the square root of 9x squared equals to 3x, and getting the square root of 25, disregarding the sign, equals to 5. Writing our answer as the product of the sum and difference of two terms, therefore, the factors of 9x squared minus 25 equals to quantity 3x plus 5 times quantity 3x minus 5. And the dimensions of the picture frames are quantity 3x plus 5 meters and quantity 3x minus 5 meters. Now, there are some cases or instances wherein we are going to use the difference of two squares more than once. For an example, we have 2x to the fourth power minus 2. Let us check first if the given polynomial has a greatest common monomial factor. Since it has a greatest common monomial factor of 2, we first take out 2. And then we divide the given polynomial using the GCMF 2. Dividing 2x to the fourth power by 2 will result to x to the fourth power. And dividing negative 2 by 2 will result to negative 1. Now let us check if the other factor is factorable using the difference of two squares. Both of the terms are perfect square, and the operation is subtraction. Therefore, we can factor it using the difference of two squares. Applying the steps, in factoring a polynomial using the difference of two squares, we get the square root of x to the fourth power equals to x squared. And then we get the square root of 1, disregarding the sign, equals to 1. Writing our answer in the form of the product of sum and difference of two terms, Therefore, the factors of x to the fourth power minus 1 is quantity x squared plus 1 times quantity x squared minus 1. But wait, if you will notice, the other factor, quantity x squared minus 1, is still factorable by the difference of two squares. And why is that? Because both of the terms are perfect square and the operation is subtraction. So, let us continue our solution. Let us try to factor x squared minus 1 using the difference of two squares. Let us get again the square root of the first expression, which is x squared, equals to x, and the square root of 1 equals to 1. Again, writing our answer as the product of the sum and difference of two terms. Therefore, the factor of x squared minus 1 is quantity x plus 1 times quantity x minus 1. And multiplying all of the factors, therefore, the complete factored form of 2x to the fourth power minus 2 equals to 2 times quantity x squared plus 1 times quantity x plus 1 times quantity x minus 1. I hope you get our example. Now, let us try to apply what we had learned and play a very simple game called mathematics block. The rules for this game is very simple. All you need to do is to determine if the given statement is true. If the given statement is true, you can type fact on the comment section. But if the given statement is false, you can type bluff in the comment section. Are you ready for our game? If you are, let us have the first statement. In 18x squared, 12x cubed, and 6x to the fifth power, the greatest common monomial factor is 6x squared. Do you think that this is a fact or is it a bluff? Start commenting your answer. And the correct answer is, it is a fact. Very good. Let us have another statement. Mario is trying to determine the greatest common monomial factor of 2xy minus 4x squared plus 6xy squared. His answer is 2xy. Is Mario's answer correct? Do you think that this one's a fact? Or is it a bluff? You still have 5 more seconds. Do you think you get the correct answer? Let us reveal. Very good. The correct answer is bluff. And why is that? Because the GCMF must be 2x, since y does not appear in the second term. Let us continue. The factored form of 3x quantity x plus 1 minus 4 quantity x plus 1 is 3x minus 4 quantity x plus 1. Are you ready to comment your answer? Is it a fact? Or is it a bluff? Go! Almost done? And the correct answer is, again, this one's a bluff. Why? Since you must also place 3x minus 4 inside a parenthesis. Are you enjoying the game? Let us continue. The factored form of 81y squared minus 49 is quantity 9y plus 7 times quantity 9y minus 7. Do you think that this one's a fact? Or is it a bluff? Five more seconds. Are you done typing your answer? Let us reveal. You got it right. The correct answer is, it is a fact. How about this one? X squared plus 100 is factorable using the difference of two squares. Do you think that this one's a fact? Or is it a bluff? You can start commenting your answer. And the correct answer is, it is a bluff. Very good. And why is it a bluff? Because the operation must be subtraction. And for our last example, Jose is trying to determine the dimensions of his table. If the area of his table is quantity 6x squared minus 9x square meters, then the dimensions of the table must be 3x meters and 2x minus 3 meters. Is it a fact or is it a bluff? Then the correct answer is, yes, it is a fact. Did you enjoy our game? So always remember that the greatest common monomial factor is the product of the greatest common factor, or the GCF, of the numerical coefficients and the constant term, and the smallest power of the variable that appears in all the terms. We can get the GCMF by getting first the GCF of the numerical coefficients and the constant term. And then we determine the smallest power of the variable. And lastly, we multiply the GCF and the smallest power. And for the difference of two squares, you must first check if both of the terms of the given binomial are perfect squares. And the operation must be subtraction. To get the square root of the first expression, and we also get the square root of the last expression, and then we express our answer as the product of the sum and difference of the square roots. I hope you understand what we had discussed for today. Now, let us proceed to your questions. So, for our first question, Sir, possible po bang ma-factor kahit na iba-iba ang variables each term? That's a very good question. So, I think it is possible to factor out using the GCMF kahit na iba-iba ang variable sa bawat term. For an example, if you have 2xy minus x squared y, still you can take out xy since the variable x and y appears in all of the terms. Let us have another question. Good morning po, sir. May iba pa po bang way sa pagkuha ng GCMF? Okay, just like what I discussed to you earlier, in getting the GCMF, you can use the process prime factorization for the numerical coefficients and constant term. And then you can also use prime factorization. You can also expand the variable and determine how many times the variable appear in each term. And then, sir, pwede po bang i-factor ang x squared plus 9 using the difference of two squares? Okay. So that's a very good question. Actually, isa sa common misconception is pwedeng i-factor ang x squared plus 9 gamit ang difference of two squares. Pero going back, on what we had discussed, you cannot factor x squared plus 9 using the difference of two squares since the operation must be subtraction. Okay. And I think for our last question, sir, paano pag nag-factor completely ka, magkaiba ng variable? So, magpa-factor completely ng magkaiba yung variable. So, again, using GCMF, you can factor out a given polynomial even though the variables are not the same as long as the variable appear in all of the terms. And also, you can also use difference of two squares even though the variables are not the same as long as the first and the second term or expressions rather are both perfect squares. For example, you can factor out the given x squared minus y squared. And the factor of x squared minus y squared is what? And that would be quantity x plus y and quantity x minus y. So thank you for all that wonderful questions. Now, we can now proceed to your homework. Kindly take a clear screenshot of your homework. Your homework can be found on your self-learning module. As you can see in our screen. You can take a clear screenshot of this or you can proceed to your self-learning module. And again, your homework will be discussed to you by your classroom teacher. Are you done taking a clear screenshot? Okay, very good. Again, thank you for listening and keep safe. Study hard.
Dahil sa COVID-19 pandemic, napilitan tayong magbago ng paraan ng pamumuhay. Ika nga nila, new normal. At maging sa edukasyon, kailangan na nating sumulong patungo sa new normal. Ang pamahalaang lungsod ng Valenzuela ay gumawa ng hakbang upang matiyak ang tuloy-tuloy na pagkatuto ng bawat kabataang Valenzuelano. Sa pakikipagtulungan sa Department of Education o DepEd Valenzuela, ilulunsad na natin sa parating na school year ang Valenzuela Live. Ang Valenzuela Live ay isang online streaming school kung saan maaaring magpatuloy ang klase ng mga mag-aaral kahit sila ay nasa kanilang mga tahanan. Paano nga ba ang magiging sistema ng Valenzuela Live? Enrollment. Sa buong buwan ng Hunyo hanggang sa ika-15 ng Hulyo 2020 ay isinagawa ang K-12 enrollment sa lahat ng pampublikong paaralan sa Valenzuela City. Nagpatupad ang DepEd Valenzuela ng mga sistema ng enrollment kung saan hindi na kailangan lumabas ng tahanan ang mga estudyante. Learning Packets. Gumawa ang DepEd Valenzuela ng mga learning materials tulad ng modules, worksheets, at study guides na naaayon sa most essential learning competencies. Ipapamahagi ang mga ito sa bawat mag-aaral sa iba't ibang paraan. Internet connectivity. Humigit kumulang 130,000 ang enrollees sa elementary at high school sa Valenzuela City para sa school year 2020 to 2021. At ayon sa isinagawang survey ng DepEd Valenzuela, tinatayang 22,000 sa mga ito ang walang smartphone. At upang tulungan ang ating mga mag-aaral na nangangailangan at mapatutunayang walang smartphone, ang pamahalaang lungsod ng Valenzuela ay magpapahiram sa kanila ng mga gadget. Ang target beneficiary nito ay ang mga kapwa natin Valenzuelano na nabibilang sa poorest of the poor. Ang magulang o guardian naman na ang bahalang sumagot sa wifi o mobile data imbis na gumastos para sa baon at uniforme. Streaming School. Kung dati ay harapan ng diskusyon ng guro at mga estudyante sa loob ng classroom, ngayon ay tablet o smartphone na lang ang magiging kaharap nila. Lahat ng leksyon ay ituturo ng mga guro sa pamamagitan ng video streaming na maaaring mapanood ng kanilang mga estudyante sa kanilang mga gadgets. Ang Valenzuela School of Mathematics and Science o Valmasay ay gagamitin bilang off-site classroom. Dito isasagawa ng mga guro ang live streaming ng mga klase. Mayroong mga IT technician at moderator na magiging kaagapin ng mga guro para sa mas epektibong online classes. Magkakaroon din ng virtual communities kung saan pwedeng magsagawa ng follow-up discussions ang mga guro at estudyante gamit ang free online platforms na hindi nangangailangan ng mobile data subscription. Maaari rin ditong gumawa ng group chats ang mga magulang kung saan pwede silang mag-usap at magtulungan upang maging mas epektibo ang pag-aaral ng kanilang mga anak. Assessment. Ang mga estudyante ay kailangang bumuo ng portfolio kung saan ilalagay ang lahat ng ginawa nilang pagsasanay na susuri sa kanilang mga natutunan. Ang portfolio na ito ang pagbabasihan ng kanilang magiging grado. Ang pagbibigay ng marka o grado ay ibabatay sa panuntunan na ilalabas ng DepEd. Ngayong new normal, walang kabataang Valenzuelano ang maiiwan. Kaya tayo na Valenzuela, magbalik eskwela na sa tulong ng Valenzuela Live.